Okay, welcome to the day 1 homework video on finding weight on Earth. So in this video, we're going to talk about weight and mass and how they are not the same. So this is our first topic, and this will also be the first topic for your Cornell notes as you write down notes. During this video, I will tell you to pause, and when you pause, there will be the time to pause the video, and I will show you what I need you to copy down. So just sit back and listen at first, and then pause to take your notes. So, weight and mass, they're not the same. Let me show you. So this is a picture of the same girl on 3 different objects. On Earth, on the moon, and just always. So her weight on Earth is 560 newtons. Put her on a smaller object. Her weight on the moon, for example, is around 90 newtons. But her mass is always going to be the same at 56 kilograms. So that's what this looks like. We have the Earth, the Moon, the Jupiter, and the Sun. As you learned from 8th grade science, all of these different objects have a different gravitational pull, and each one also has a different mass. The larger the object, the larger the gravity. That was something you guys learned in 8th grade and did really, really well on the pretest when I asked you that question. So we have the Earth, and notice this little stick person always has a mass of 63.5 kilograms, but has a different weight. For example, on the Earth, we get a weight of 140 newtons, a weight of 103 newtons, or in America we call it 23 pounds. In Jupiter, it's 1,582 newtons. In America, we would call that 355 pounds. And then on the Sun, the largest object in our solar system, the weight is massive at 17,418 newtons, or 3,914 pounds. So, you weigh 140 pounds on Earth, go to the Sun, you weigh a lot more. So to summarize, the difference between mass and weight is that mass is a measure of the amount of material an object is made of. It is measured in kilograms, and we usually put it on a scale such as this, and it reads us a number. However, weight is the force of gravity on that object, and it is measured in newtons. And as you became familiar with, we've got our handy dandy force arrow showing us the force due to gravity. So what I would like you to do now is pause this video and copy the difference between mass and weight into your notes. Okay, great. I hope you have that written down. Next, we're going to move on to how we actually calculate this weight. So as you remember, force is equal to mass times acceleration. This is an equation we came to know and love in our last unit on Newton's laws. Force is equal to mass times acceleration. We shortened that into being F is equal to ma. We're going to use that same equation. We're going to use that same equation, except instead of saying force, we're going to call it weight. Mass is still the same. Acceleration is still there, but we're going to actually call this acceleration due to gravity. Okay? We can shorten that by saying W is equal to mass times G. Okay? Or W equals mg. We're going to use this mg a lot in this upcoming unit, so this is something you're going to want to become pretty familiar with. And as always, when we get a new equation in science. We want to make sure we know what all of our variables mean in our equation. And we also want to make sure we know our unit that's being measured in. So W is the W due to gravity, or I'm going to call it weight due to gravity. This is called weight, and we're going to measure that in newtons. Okay, so weight is a force, and it's measured in newtons. M is the same that we've come to know and love. Mass is in kilograms. Now G, okay, is going to be our new special acceleration here on Earth, and that's the acceleration due to gravity. On Earth, that acceleration due to gravity is always going to be 9.8 meters per second squared. This is a number that's going to become very important in your life. In our next 2 units, we're going to use this number over and over and over again. So this is a number that you're probably going to want to memorize and take some time to remember. So our example problem here is, what is the weight of a boy with a mass of 35 kilograms on Earth? So let's go ahead and solve this problem. So first off, the problem is asking us for what is the weight. We're going to collect our numbers. In this case, we only have one number, and that is equal to 35 kilograms. And our equation that we learned in our notes is weight is equal to mg. I have a problem. I'm only given one number, but my equation is telling me to multiply 2 numbers, m and g. But we have to remember that acceleration due to gravity, or g, is equal to 9.8 meters per second squared. Again, a number you're just going to have to memorize. Sometimes problems will say use 9.8 meters per second squared, and that gives you a clue that that's a good number to use. So now we just substitute. So we have W is equal to 35 times 9.8. And when we do that, we get an answer of,
Did you know
and I actually have to calculate that out. It's equal to 343. And just like with our units of force and F equals ma and W equals mg, our units are still the same, 343 newtons. So what I'd like you to do now is go ahead and copy this into your notes and pause the video. Okay, great. Now we're going to do another example problem, very similar. So this is another opportunity to pause this video and copy this into your notes. This time you have a new heading in your notes, and that heading is called Equation for Weight on Earth. And I want you to pause this and copy this into your notes. Okay, great. Good job. I'm glad you paused that and copied that into your notes. Next, we're going to see how we can solve this example problem. What is the weight of a dog with a mass of 10 kilograms on Earth? What I would like you to do is pause the video and try it. Try it in your notes and see what happens. Okay, good. I'm glad you tried that. Now I'm going to show you how to solve it, and you can check your notes to see if you did it right, and then correct your notes if you made any mistakes. So again, we're going to collect our unknowns. So it's asking, what is the weight? So weight is equal to our question mark. We have this relationship, weight is equal to mg. We know that our mass is equal to 10 kilograms. And because we've memorized it, we know that little g is equal to 9.8 meters per second squared. So when we substitute that out, we get weight is equal to 10 times 9.8, which is equal to 98 newtons. So check your answer in your notes. Did you have everything? Did you have that you put? Did you put the newtons? Did you have the correct answer? Did you show your work to get all 5 points? Okay, there are still people who are not showing all their work and they're not getting any credit for their assignments and for their test scores. So please make sure you're showing all of your work. All right, this is the end of the video. You can now stop watching the video. In order to get credit for watching this video for your homework, you will need to first finish these Cornell notes. What I mean by finishing Cornell notes is to first write 2 to 3 questions and a summary for your C notes that you took. So 2 to 3 questions and a summary. Once you've done that in your science notebook, you need to open up your iPad to Shobi. Under Shobi, you will find an assignment titled Day 1 Mass and Weight Homework. You will simply need to add the picture that you took of your notes into that assignment, and I will give you credit for watching this video. Thank you very much for watching this video, and I look forward to helping you solve these type of problems in class next time I see you. Thank you. Great. I'm glad you have finished that video. That's it. That's all. Thank you for doing this homework and look forward to seeing you in class. Bye.